Before you go any further, let's take a quick moment to look at the truth tables for logical and logical or. Now, truth tables are just a way of representing all the possible combinations of inputs for a logical expression. Here I have the truth tables for logical and logical or. The way to read these tables is the first two columns, A and B, are representative of Boolean values. When both of these values are combined, the third column represents what the resulting outcome would be for logical and logical or. Now, what's interesting about these tables, and you might have noticed this already, is that in some combinations, the value of B has no impact on the result of the logical expression. Let me highlight these tables in another way so you can see what I mean. There we go. So if you look at these rows, you'll notice that regardless of the value of B, the value of A is the value that's actually determining the result of the logical expression. For logical and, if the value of A is false, the value of B doesn't matter. The combined value will always be false. And for logical or, if the value of A is true, then the value of B doesn't matter because the combined value will always be true. And this makes sense. Just think about it. In our previous example, where we were trying to decide if Julia was going to the park, two conditions needed to be true. Colt had to not be busy and the weather had to be nice. If the value for the variable Colt happened to be anything other than not busy, it wouldn't have mattered if the weather was going to be nice. Julia would not have gone to the park because both conditions weren't true. This type of behavior is called short-circuiting because later arguments in the logical expression are not considered because the first argument already satisfies the condition. For logical and, if the first value is false, you don't need to see what the later argument is going to be. The entire expression will always evaluate to false. And for logical or, if the first value is true, you don't need to see what the later arguments are going to be because the entire expression will always evaluate to true.